All right, we're going to talk about section 5.5, which are half angle identities. So when we look at this, we've been given double angle and half angle identities. So we see basically that if we take sine of 2 theta, it's 2 sine theta cosine theta, and then cosine of 2 theta is cosine squared theta minus sine squared theta. And these really come from our sum and our addition identities, right? So 2 theta is just theta plus theta, and if we apply the addition identity that we had before, we get sine theta cosine theta plus cosine theta sine theta, and we combine that into that value. So these really just come from a application of our addition identities. So we can use them to solve problems very kind of the same way that we did before. So if I'm looking for some values, so I've been given a sine value, I have an interval, and I'm sorry, given a sine value, and I want to find sine of 2 theta. What I need to think about is, first off, what interval does 2 theta drop me into? If I double everything here, so multiply that by 2, I get 2 pi, and then 3 pi over 2 by 2, and I get 3 pi. So between 2 pi and 3 pi is going to be my end interval when I double it. And then I'm just going to basically plug through. So I know that I have sine, and I can figure out from there, I can figure out cosine by basically applying the triangle. So you'll see over here that I could go back 7, and then, back 24 and down 7. And then I can use the Pythagorean theorem to figure out 25, and then I have my ratios, and I can figure out sine, cosine, and tangent from there, which is all they did here. They just applied opposite, adjacent, opposite hypotenuse. So once we have those values, we just apply the identity. So 2 sine of 2 theta is 2 sine theta cosine theta. I now know those ratios, and so I can figure out my value. Same thing with cosine of 2 theta. I know those ratios. So the key with this problem is, given a value where I am, I then need to figure out, using the Pythagorean theorem, my other ratios and go from there. This is another way this might look. So same idea, where I have a cosine value, and I'm then trying to figure out my other ones. So to do this, I'm going to first off need to figure out where I am. I'm right there, 0 to pi over 2, which means I have a positive cosine and a positive sine value. And given a cosine value, I'm going to find a sine value using the Pythagorean identity. So sine squared plus cosine squared is 1. I substitute in the given value of 3/5 into cosine and square it. And then I just plug through the math and try to figure out my sine value. I'm going to get a plus or minus on this value, and I know that since I'm up here in this quadrant, that means that this value has to be positive. So I know that I'm going to have a positive value. Now I just need to do is apply the double angle identity. So I know that that is 2 sine of theta cosine theta, and I know those ratios. I've just figured them out. I just plug it in and then go through the math and go from there. For this one, for my values, I have cosine squared minus sine squared theta. I just plug in my values and then go from there as I'm looking at it. All right, so let's say that we have an equation using the double angle identity. My first part is I see that right off the bat I have a double angle and have a sine. We want to be careful. This is not sine of 2 theta minus sine of theta is not sine of theta. I don't subtract them that way. I'm going to take the sine of 2 theta and apply the identity, 2 sine theta cosine theta, factor out sine of theta, and then once I have two things that multiply and equal 0, right, then I know that either one has to be 0. So from my zero product theorem, I know that each is going to have to be 0. That's what they've done right here, and that's what they've done over here. We work through it and solve it, and then thankfully these are unit circle values, and we know the interval that we're on. So we basically look what values of theta give me a sine value of 0. Well, that's 0 or pi on when I'm on the x-axis. And then when I have a cosine value of 1/2, that's going to be my values of pi over 3 and 5 pi over 3. So you need to, again, you're restricted to a certain range, a certain interval, and then you're going to break it down until you get your unit circle values to go from there. All right, so if we were to take that same idea and work out a problem like this, I want to first off bring everything to one side. So I get cosine of 2 alpha plus sine squared of alpha equals 0, and then I apply the double angle identity for cosine, and from there I get cosine squared alpha minus sine squared alpha. I've added a sine squared alpha, and then thankfully those sine squareds are going to go away, and I get cosine squared alpha is 0. Take the square root. The square root of 0 is 0, and I know that I'm looking for an alpha value that gives me a cosine value of 0. So what that means is I'm going to be on the y-axis. So my cosine value is going to be 0 when I have pi over 2 or 3 pi over 2. All right, so again, our strategy, bring it all to one side, apply the identity, and then see what you can make drop out, trying to get back to a unit circle value that you can have a known angle for. All right, these are half angle identities that look a little bit scary, but we have this square root, and then we have a plus or minus in front of that. We got to think about kind of where those values are going to go. So if I have a value, it's the same process as before. I have 112.5, and I need to think about how do I relate that to a unit circle value. So I need to bring it back to a known value. So what we see here is that 225 is on the unit circle. And so we can plug in using our half angle identity. Right, cosine 112.5 is cosine of 225 over 2. We apply the identity, and this here, cosine of 225, is a known value on the unit circle. It's root 2 over 2. And from there, we just have to plug through the math. That's going to look a little bit scarier, but it should be okay. And we get all the way down to our exact value at the bottom. So we just use a unit circle value, and then we go through using our radicals to get an exact value. And you'll see here, this is the exact. You can plug it into your calculator to see that it's actually working with the approximate value. So if I was to take 75 degrees, there's two ways that I could look at this. One is that this is 45 plus 30 degrees. That would work, and I'd use an addition identity. But the way that we're going to look at it is if it's half of 150 degrees. So we'll use the half angle identity to see what we're looking at. So I know with my half angle identity that sine of 75 is the same as 1/2 of 150. And so I can apply the identity, right? So all I've done is I've taken my angle, I've rewritten a little bit, and now I see I have a half angle identity which plugs into this. Cosine of 150 degrees, that's a unit circle value. If I can't remember, I look at my reference angle, so that's 150, means that's 30. So I have my 30, 60, 90 triangle, it looks like that. Up a half, back negative root 3 over 2. My cosine value is my x value, so that's negative root 3 over 2. So I plug that in. So that becomes my angle, and now I just combine. So I have 2 plus root 3 all over 2, and then I divide by 2 again. And so I get that value over 4. My last piece, I have to figure out the positive or the negative value. Well, if I think about where 75 degrees is, right, that's up there in my first quadrant, which means I have a positive cosine value and a positive sine value. And so I'm going to pick the positive of the two. All right, so again, try to break this into known angles on the unit circle. You'll apply your identities, and then hopefully things will start to simplify and you can solve your problems. Same idea with this, right? We're going to bring everything together. We have a half angle for cosine squared, which is basically that half angle. We're not factoring this out, but this is cosine of pi over 2 times cosine of pi over 2, which is just the squared value, which is thankfully going to get rid of that square root. So again, we apply the half angle identity, we simplify, and now we're left with this piece here where I have sine squared on one side and cosine on the other. It's going to be helpful to get rid of, to make a substitution so that everything is either sine or cosine. I have an easy way to relate cosine squared and sine squared using the Pythagorean identity. So now I have everything in terms of cosine. I can bring it all to one side, and I see that I can factor out a cosine, and now that I've gotten to this point where it's multiplication and 0, I apply my zero product theorem, which means that each of those is 0, and I can solve for my angles. All right, that's it.